Welcome back. Problem 12-49. And this problem is taken from chapter number 12, that is Deflection of Beam and Shaft, and book name is Mechanics of Material by R.C. Hibbeler. So statement is determine the displacement C and slope at A of the beam EI is constant. So you can see this is overhanging beam and loading shown from C to A there is a uniformly distributed load, and then from A to B there is a uniformly decreasing load or triangular load. X start from here, total length of the beam is 15 feet, and at point A there is a roller support, and at point B there is pin support. So you, due to this loading, the beam will deflect like this. Clear? So we have to find the displacement of at point C, which is VC, and the slope, which is the slope theta A, which is equal to tangent of this line. So let's start with the solution. Step is that if you remove the roller support at point A, so you will be having reaction force, which is represented as RA. And if you remove this pin support at point B, so you will be having a horizontal reaction force, which is equal to RBX, because it's horizontal component, and there will be a vertical component as well, which will be RBY. So we have taken RBY downward. You can take it upward, and when you calculate it, if the value comes out to be negative, it means that your selected direction is wrong and it should be in opposite direction. So you'll find this RA, RBY and Rx by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0, and force in this direction is taken as positive. So you can see only there is a one horizontal force, which is RBX, and there is no other force. So RBX, it means that RBX is equal to 0. So this pin support does not offer horizontal reaction force. Now we will find this RA and BY by using another equation of equilibrium, that is sum of all moments about point B is equal to 0, and taking the counterclockwise movement as positive. Before doing this, you can see there is a distributed load, uniformly distributed load from A to C. So when this is converted into a point load, so you have to multiply this distributed load of 8 kips per feet with the length, which is 6, and this will be equal to 48, and this will act at a distance of half of the 6 feet. So it means that this distance is 3 feet. And there is a uniformly decreasing load from this point till this point, and when you convert this load into a point load, so it will be, as it is triangular, so area of this triangular is 1/2 into 8 into length, which is 9. So I will convert this uniformly decreasing load or triangular load into point load, and it will be equal to 1/2 this magnitude of 8, because this is the maximum, into length, which is 9, and this will be equal to 36. Now it is acting at a distance of L/3 from this denser side. This is the denser side. So this distance will be L/3, and the length of this over portion which it is act is 9. So 9/3 is equal to 3. So this distance will be equal to 3 feet. And the remaining this distance will be equal to 6 feet. Okay. Now sum of all moment about point B is equal to 0. So these two forces do not produce any moment, because it is passing through this point. So first moment will be produced due to this load, which is equal to this 36 into perpendicular distance is 6, and this is producing counterclockwise movement, so it will be positive. The second movement will be due to this RA into perpendicular distance 9, and this is producing clockwise, so it will be negative. The third movement will be produced due to this 48 load, and perpendicular distance is 12, and this is producing counterclockwise, so it will be positive. And the sum of all moment about point B will be equal to 0. So I will write first 36 into 6 minus 9, which Ra into 9, Ra into 9 plus 48 into 12 is equal to 0. So from here you will get 36 into 6 is 216 minus 9Ra plus 576 is equal to 0. So it means that 9Ra is equal to 792, and when you divide 9 on both sides, so you will get Ra will be equal to 88 kips. Ra value is positive, so it means that you have taken the direction of Ra is correct. Now we will find Rb by using another equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see Rb is downward, this 36 is downward, plus Ra minus 48 will be equal to 0. So I will write minus 48 minus 36 plus Ra, which is 88 kips, minus Rby is equal to 0. So when you calculate it, you will get Rby will be equal to 4 kips. Since this value comes out to be positive, it means that you have chosen the Rby in downward direction is correct one. Now you have all these forces, so we will find the equation of elastic curve by using the equation EI into d square V over dx square is equal to moment. So we'll find the moment by using discontinuity equation or using Macaulay's method. Now you can see that this beam having loading or uniformly distributed load, then triangular load, then you have a point load. So it's a mixture of all the loads, and you can see the table below having point load, distributed load, and triangular load and their moment function. So for this beam we will calculate this M by using this moment function. So if I draw the free body diagram of this beam, so it is like this. We have, let this point is Ra, so we have Ra is 88 kips, clear, and there is a uniformly distributed load of 8 kips per feet, and then triangular load which is downward. Now from the table you can, and there is Rb y which is downward, and this Rby is 4 kips, and there is no Rax which is 0, Rbx. Now you can see from this table that for point load we have a moment function is this one. For distributed load, so distributed load start from this till the end. If A is equal to 0, it means that it start from till end. And here you can see the load is, distributed load is from till up till of length of 6 feet. So what we will do is that we will add a triangular load like this to make it completely distributed load, and in downward direction we will subtract the same in upward direction. So let's do this. We will choose another color. We will add the same load in downward direction. Okay, and in downward direction we will add the same thing, but will be in the upward direction. This point start from there. Okay. And this magnitude here, this is total 8. So this will be also 8 kips per feet. Now let's start with the moment function. So I will write moment will be equal to First, we will consider this distributed load of 8 kibs over the whole length, and for this we have function m is equal to w naught over 2 into x minus a. So w naught here is 8, so 8 by 2, and this load is downward and here load is upward, so this moment is positive. But here the load is downward, so it will be minus 8 by 2 into x minus a is equal to 0 because movement start from here. A is equal to 0 for this load and x start from here. So x minus 0 power 2. Okay. The second movement that is produced due to this load, this point load, which is 88, and this is upward. So for point load, the function is this one. So I will write plus p into x minus a is here 6 feet because x start from here and this load is at a distance of 6 feet. So x minus 6 power 1. The third load is triangular load, and you can see this load is like this. So for triangular load, the moment is m by 6 into x minus 6, x minus a power 3. What is m? So m is the slope of this curve. Slope is equal to tangent theta, which is equal to perpendicular, and this perpendicular is 8 divided by this base, which is equal to 9 feet. So 8 by 9. Clear? And this load is upward, and here the load is also upward, so it will be plus, you can see m by 6. So m is 8 by 9 into 1 by 6, which is m by 6 into x minus a. A is 6, so x minus 6 power 3. And we will neglect the last load RBY. Okay, so this is the function. Let this is equation number A. So put value of m in equation A. So you will get EI into d square V over dx square will be equal to minus 4x square. Clear? And this term 8 by 9 into 1 over 6 will be equal to plus 4 over 27 into x minus 6 power 3, and this term will be equal to plus p. So p here is 88. Okay, this is 88. So 88 into x minus 6. What we will do is that integrate it. So when you integrate it, you will get EI into dV over dx will be equal to minus 4x cube over 3 plus 4 over 27 into x minus 6 power 4 divided by 4 plus 88 into x minus 6 power 2 divided by 2. And if you further simplify it, it will be equal to minus 4 over 3 x cube plus x minus 6 power 4 divided by 27 plus 44 into x minus 6 whole square, and there will be a constant of integration as well over here, plus C1. So C1 will be over here. Let this is your equation number 1. Now what we will do is that again integrate equation 1. You will get EI into V is equal to minus 4x power 4 divided by 3 into 4 plus 4, this is x minus, this is the equation, this one, x minus 6 into 5 divided by 27 into 5, clear, plus 44 into x minus 6 power cube divided by 3. plus C1x plus C2. And again, if you simplify it, it will be equal to minus x4 over 3 plus x minus 6 power 5 divided by 135 plus 44 by 3 into x minus 6 power 3 plus C1x plus C2. This will be equal to EI into V. Let this is your equation number 2. Now C1 and C2 are unknown constant of integration and they can be found by using boundary condition. So I will write boundary conditions. So first boundary condition is that at x is equal to 6 feet, we have deflection is equal to 0. So let me show you here x is equal to 6 feet, we have deflection is equal to 0 because there is a roller support. So put it in equation number 2. When you put it in equation number 2, so this is equation number 2. So EI into V, which is 0, is equal to 0, and minus 6 power minus 1 over 3 into 6 power 4 plus 6 minus 6 power 5 divided by 135 plus 44 over 3 into 6 minus 6 power cube plus C1 into 6 plus C2. So this term will give you minus 432. This will be 0 because 6 minus 6 is 0. This term will be 0. So we have 6C1 plus C2 is equal to 0. So from here you will get 6C1 plus C2 is equal to 432. Let this is your equation number 3. Now the second boundary condition is that at x is equal to 15 feet, we have deflection is equal to 0. So let me show you here. Here x is equal to total length is 15 feet and we have deflection is equal to 0 because there is a pin support at point B. So put in equation number 2. So what you will get, EI into V is equal to 0 is minus 1 over 3 into 15 cube 15 power 4 plus 15 minus 6 whole power 5 divided by 135 plus 44 by 3 into 15 minus 6 power 3 plus C1 into x, which is 15. So 15 C1 plus C2 is equal to 0. So again you will get this is equal to 0. All these terms will give you, when you calculate it, will give you minus 5745.6 plus 15 C1 plus C2 is equal to 0. So from here you will get 15 C1 plus C2 is equal to 5745.6. That this is equation number 4. So equation 3 and 4 are simultaneous equation, so you can easily solve this. So solve equation 3 and 4 simultaneously. You will get C1 will be equal to 509.4. I hope you can do this step by your own self. So these are the value of C1 and C2. Now in first part we have been asked to find the displacement of point C, and in second part slope of point at A. So for displacement, what we will do is that put the value of C1 and C2 in equation number 2. This is the equation number 2, and divide EI on both sides. So you will get deflection is equal to 1 over E into I into minus x power 4 over 3 plus x minus 6 power 5 divided by 135 plus 44 over 3 into x minus 6 power 3 plus C1, which is 509.4 into x plus C2, and C2 is minus 3110.4, and the unit will be, after putting the value of unit of E and I, so you will get the unit will be in feet, or you can just say it is keeps into cubic feet, and when you put the value unit of E and I, so definitely it will convert into feet. Now we have to find V at C, so it means that you have put x is equal to 0, so you will get VC. So put x is equal to 0 in this equation, so this deflection will be equal to VC, or V at x is equal to 0, and this will be equal to 1 over E into I. This term will be 0 because this term will be equal to minus 6 if you put x. So anything that is negative inside the Macaulay bracket will be 0. Similarly, this term will be 0, this term will be 0. So we will left only with this term. So it will be equal to minus 3110.4. And this will be equal to minus 3110.4 divided by E into I. And it will be equal to, unit will be kips into cubic feet. So if you have the unit of E and I, so you will put at the end, you will get this VC will be equal to minus 3110 divided by E into I kips into feet. The negative sign shows that displacement or deflection will be downward. So this is the answer of our first part. Now we will move toward next part, that is to determine the slope at A. So what we will do is that we will copy the equation number 1. So where is equation number 1? So let me copy it. This is equation number 1. So remember the value of C1 and C2. This is equation number 1. So put C1 in equation number 1 and divide EI on both sides. You will get dV over dx is equal to minus 4 over 3 into x cube plus x minus 6 power 4 divided by 27 plus 44 into x minus 6 power 2 plus C1, and it is wholly divided with 1 multiplied with 1 over EI. Okay. C1 value was plus 509, so I will replace 590.4. Now we have to find the slope at point A. So here x is equal to 6 feet, and I have already shown you, due to this the deflection will be like this. So slope at this theta A will be equal to at 6 feet. So when you put x is equal to, at x is equal to 6 feet, we have dv over dx at x is equal to 6 is equal to slope at A. So dv over dx is theta, and that will be equal to minus 1 over EI into minus 4 over 3 and 6 cube plus 6 minus 6 power 4 divided by 27 plus 44 into 6 minus 6 square plus 590.4. So this 1 over EI, clear, and this term will be 0, this term will be 0, and the sum of this term and this term will give you 302, 302, and the unit will be kips into cubic feet square, theta A. Okay. And theta A slope at point A is equal to 302 divided by E into I, kips into square feet. So this is the slope at point A, and that is the answer of our second part. And that was all about this problem 12-49. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.